Alright, so this should be a quick one, but you're going to have to watch some other videos. This is how heat transfers. How does it go from one place to another? How does one material, or how does the energy get from one place to another? And there's basically three different ways. And those are conduction, convection, and radiation. Right? So, when we're talking about conduction, okay, what you're talking about is a transfer of thermal energy. That's thermal energy going from one place to another. So that's heat, and that's via direct touch. Okay. Wow, that's terrible handwriting. But when I take my hand and I put it on the desk, my hand is 90 degrees, something like that, and it touches the desk, and the desk is probably 72 degrees room temperature. So my hand is hotter. It's directly touching it. My hand transfers heat to the desk. So the energy from my hand goes away, so my hand gets cooler, and the energy goes to the desk, which gets warmer. Now what's actually happening is the molecules in my hand, which are moving around, not much, but they're moving, they're wiggling and jiggling, they actually hit the molecules that are on the table. So you've got the hand and let's say a clipboard is the table. The molecules are actually bumping into each other. And so the faster moving ones are hitting the slower moving ones and speeding them up. So these get slower and these get faster. That's what's going on with conduction. That doesn't just happen when two things touch. That happens when something is being transferred. Like if I took this metal thing and I had like a lighter or something, I heated up this end, okay? The whole thing doesn't get hot. This end will get hot right away, and then all the molecules will continue to move across and bump into the slower ones, and slower ones pick up heat, or pick up energy, and then they hit other ones, and they hit other ones, and then the heat or the energy slowly transfers. Okay, that's what's happening. It's kind of like a big game of maybe not dominoes, but something close to dominoes. Okay, that's what's going on. So what's happening? Well, we're talking about molecules, like I said, bumping into each other, and transferring energy. Okay, so you got to actually have that physical touch in order for conduction to occur. So what I'm going to do is on Moodle, you will see that there are some videos, okay, by Julius Sumner Miller. There's part 1 and there's part 2. So go ahead and make sure that you watch 1 and 2, parts 1 and 2, and write a couple examples of conduction in here. All right, so that's conduction. Now, convection is different. You might have heard of a convection oven. You might have heard it in the oceans, convection currents, that sort of thing. So, now it is a method of heat transfer, so it's a transfer of thermal energy. But this time, we're talking about fluid movement. Now, what do I mean by fluid movement? Okay, what's happening is a fluid, which could be... oh, this isn't working. There we go. Okay, we have a fluid, like let's say could be water, could be air, okay, but typically it's some sort of liquid, even though air is not really liquid. Let's just go with water or air for now. All right, but it's a fluid. It's something that takes the shape of its container. It's moving, okay, and the fluid is moving around, and because it's moving around, it's taking thermal energy or heat from one place to another. Okay, that could be, for example, in a lava lamp. You have the very hot lava. It's not lava, it's just some gel looking stuff, but it gets hot and then it goes up and it moves that because it has a thermal energy. It moves the thermal energy up, and then by conduction it transfers heat to the water around it. But the idea is that this fluid is the actual motion of the object, of the fluid, that moves it from one place to another. Okay, this happens in the oceans, okay, the ocean currents. This happens in the atmosphere. In particular, you feel one probably every day, wind. Okay, you can do it in an oven. The idea with a convection oven is if you just put a cold turkey in a hot oven, the air around the turkey gets colder than the air further away from the turkey because it's touching it. But if you constantly move that air, fan the air around, you get the hot air touching that turkey again, and it heats it up, okay, a lot faster. That's why convection ovens are more expensive, and they cook faster. Okay? Don't eat turkey. Eat tofu. All right. Lastly, oh, by the way, watch Julius Sumner Miller for this. Okay, he's got another one, parts 1 and 2 for convection, and write a couple more examples down here. All right, I don't know why you'd eat turkey. That's just weird. Now, the last one is radiation. Now, this is interesting. Okay, see, conduction and convection, you needed a material. You needed something to touch something else or something to move. But this case, radiation, you're transferring thermal energy, but you're transferring it via electromagnetic waves. Okay? What we're talking about here is, or in one case, there's no medium necessary. Okay? This is in cases such as the sun. Okay? The sun transfers its heat via light and infrared radiation and a whole bunch of different ones. In fact, I don't know if you can see it, but we've got a whole bunch of the electromagnetic spectrum up there. The sun is actually giving all of those wavelengths out. But that doesn't need a material. See, sound needs a material to go through. Heat needs a material to go through normally with conduction or convection, but infrared waves, light waves, X-rays, all kinds of electromagnetisms, they don't need a medium. They can go through nothing. Okay? I guess you could say space-time is sort of a medium, but ignore that. In other words, even if there was nothing between us and the sun, the Earth and the sun, which there pretty much isn't, if there was absolutely nothing, you would still feel the heat from the sun. Okay? You also can feel this in a campfire. Okay? When it's all burnt down and all you have is the hot coals, that's infrared radiation hitting you. And you can block, let's say you're too close and it's too hot. All you got to do is hold your hands up, block that heat, block that infrared radiation. Your hands will get hot, but your face won't anymore. Okay? It's not that it's so hot because it's touching the air and the air's touching you. No, that's actually radiation touching you. That's why when you hold up your hands, it blocks that heat. Other forms of radiation. I mean, we're talking infrared. That's usually the one we talk about. But any kind of radiation. I mean, even radio waves is a form of this. You've got UV. Trying to think, X-ray. I mean, there's a lot more than that. But the idea is that there is no medium necessary. But you do need something to absorb it. And as you guys know, articles of clothing that are darker absorb more of the radiation than the articles that are lighter. Because the white shirt is going to reflect all of the light, okay, or most of the light. It's going to reflect most of the light. But then the black shirt is going to absorb most of it. My purple shirt here absorbs a lot of radiation from other sources. Another source of radiation would be your body, actually. Your body has about 98.6 degree heat, or sorry, temperature, 98.6 degree temperature, and because it's warm, it actually gives off radiation. That's how Predator finds you. That is how infrared goggles work. They sense things that are warmer because warmer things give out more infrared waves. But anyway, that's really all I can think of now. But the idea is that you've got, as far as all this goes, you can either transfer heat by conduction, by convection, or by radiation. And if you have any questions or you came up with any good ideas, see me tomorrow and ask it in the beginning of class.